Hello Precalculus student, this video is for chapter 4.4 Graph of Log Function Part 2. We're going to look at some particular of log functions, in particular domain, range, x and y, intercepts. So one thing that we mentioned twice in the last video is to find a domain, we just look at the log inside. We know that it was the output of an exponential function and it must be positive. So x plus 4. To find domain, you just solve whatever inside is greater than 0. So x is greater than -4. And so that's the domain. So greater than -4, that means from -4 all the way to infinity in interval notation. And then range is, don't have to think, it's just all real number, -infinity to infinity, because that was the domain of the exponential function. Now, what about x-intercept? X-intercept is a little harder. Let's do y-intercept first. Y-intercept is when x is 0, right? So you would say y equal to -2 log, plug in x equal to 0 here, log 4 plus 5. So that is it. This would equal to, yeah, it would just equal to this number. If you put in the calculator, log 3 to the 4. Log 3, not log 3 to the 4, but log 3, 4. So if you put in the calculator, it will be -2 times log base 3, log base 3 divided by log 4. Well, I think we'll just do it, put it like that, and that would be our y-intercept without calculating. What about x-intercept? X-intercept is more involved because basically you would set y equal to 0. That means 0 equal to -2 log base 3 x plus 4 plus 5. You have to solve this. You have to solve for x, right? So to solve for x, you want to isolate the log on one side. So so you would have a -5 equal to -2 log base 3 x plus 4, right? And divided by -2. So you end up having divided by -2. I'm going to do it here, continue here. Not enough space. It would be 5/2 log equal to log base 3 x plus 4. So this is a log expression. I'm going to rewrite it as a exponential expression. So this was the input of log, so that would be the output. So, and this is the answer. So that means 3 to the 5/2 is equal to x plus 4, right? The input and output switch. So x would be 3 to the 5/2 minus 4 is equal to x. So this is the x value. 3 to the 5/2 minus 4 comma 0 is the x-intercept. The y-intercept is this number 0 of this number. It's rather difficult. And then let's find this one. What is the x and y domain? Domain is the inside positive. Negative x is equal to greater than 0. That means x is less than 0. So that means from -infinity to 0. And the VA is x equal to 0. So you don't care about the outside, it's just the inside. Range is all real number. -infinity to infinity. Y-intercept is plug in x is equal to 0, right? So it'll be ln -0 plus 3, which is undefined, right? So it is undefined, so no y-intercept. So if you plug in anything that is negative inside, because it's outside of the domain, 0 is not part of the domain. X-intercept is to solve the equation, right? To solve 0 equal to solve y equal to 0, solve for x when y equals 0. So ln -x plus 3. That means -3 equal to ln -x. So this is a exponential, this is a log notation. I'm going to write it as e to the -3 is equal to -x. So x would equal to negative of e to the -3. So I don't have y-intercept, but my x-intercept is negative e to the negative 3, comma 0. So that's how you find the x and y intercept. So actually go into graphing now, because this is the topics of this 4.4. 4.4 is to graph exponential function, log function. So in a nutshell, after we know how to graph the two types of parent function earlier, graph, well, yeah, log base bx, it will be in general like this. You graph by graphing the exponential function, or graph log bx where b is less than 1. It's like that. And ln x is kind of like that. So all of the other one, you would just use the those function as a parent function and then do transformation. So when you have add and subtract inside, that is shift left or right. Okay, if it's a plus, it's shift to the left. If it's a minus, shift to the right. If you add and subtract outside, that is up and down. Okay, so that's horizontal and vertical shift. Reflection would be multiplying negative. If it is negative inside of the log, that is reflection over the y-axis. If it's a negative outside of the log, that is reflection over the x-axis, up and down. Compression and stretch will be vertical stretch. You have A inside. A would be it would be a stretch if A is the absolute value of A is greater than 1. It's a compression or a string if A is less than 1. Now they don't talk about horizontal, and there's a reason for it. When we talk about properties of logs, you can tell that we don't need to consider multiplying a number inside of X, which is the horizontal strength and stretch, because it could easily be converted into a vertical shift. Use transformation to sketch the following function. So we want to graph ln negative x. So we would know that what kind of transformation is this? Write down the transformation. The transformation is negative inside, that is a reflection, right? Reflection over not the x-axis, but over the y-axis. And we know the log x function is like this. I'm going to dot it, kind of like that. That is the ln x parent function. So if I want to do ln negative x, that would be on this side. So I'm going to graph solid. Just do everything here. So this would be y equal to ln negative x. That's just reflection. So this is log 4x, but with a negative 2 outside. So whenever we see negative, we know the transformation is reflection, but because it's outside, it's reflect over the x-axis. And there is a 2. 2 is greater than 1, where absolute value of negative 2 is 2. So this is a vertical stretch by 2, right? So to graph it, we'll graph the log 4x first. What is log 4x? Log 4x is, I'm just dotted it this way, right? You would have a 1 here, and then this is an asymptote here, right? VA equal to x equal to 0. Now I'm going to do the reflection up and down, so it would be like this, and then stretch. So that means kind of stretch down and stretch up more, but this would be y equal to negative 2 log 4x. This is the parent function log 4x. Okay, so that's how you do. Is you don't have to like build table and such. Just as a sketch is fine. So what is the transformation here? We have something subtract inside. It is horizontal shift. Left or right? It's a right 3. So the whole graph move 3. Now let's graph the original log base 10. So this is log base 10. The original log base 10 is like this, right? Oh, let me dot it. Log base 10x or just log x. But negative 3 means move to the right by 3. So your VA now become, so x is equal to 3. And then your new graph would be like this. The same, but I think there's some overlap. Log base 10, x minus 3 because it moved to the right with the new vertical asymptote of x equal to 3. But this one, log 3x minus 4. So this is a parent function because it's just log base bx. And then minus 4 means down 4, right? So I don't move anything. It's just the whole thing shift down 4. Log 3x because 3 is greater than 1. Again, it's always like that. Have a 1 here and then grow very slowly. So this is just log 3x. Down 4 means the whole thing's just shift down 4. So instead of having the x-intercept like this, my 1 would be here, right? So this would be like that. Eventually, it would go through and touch the x-axis. So this is log 3 base 3x minus 4. It's down 4. Okay. So that is graphing and then summarizing the transformation of log function. If you see things adding and subtracting inside, so the inside is left and right, the outside is up and down. Negative is reflection, and then if you have an A outside, that is vertical stretch transformation. Now, because the only time you move the vertical axis is if you move inside left and right, so the vertical asymptote is always x equal to negative c, right? And the x-intercept is a comma 0. If you have an A, then it's log base 0. Comma 0. Is it 0? Yeah, a comma 0 because if log 1, so if x is equal to 1, then you have a. Okay. And then for end behavior, it is one-sided only. So if you look at a parent function, either this way for log base b, where b is greater than 1, or there's only two types, right? Or this one. So both of them will have what? Will have when x approach 0, so they y will approach either infinity or y approach negative infinity. In this case, y approach negative infinity, right? And this approach 0. So, but this is not the end behavior. The end behavior is when x approach infinity. When x approach infinity, y would approach. In this case, y would approach infinity, and in this case, y would approach negative infinity on this side only. So, and then the next section is so that's all for graphing, and I will go over 4.5 properties of log functions. In terms of end behavior, I won't say this is the end behavior. This is kind of like the vertical asymptote behavior, like this. The end behavior would actually be when x approaches infinity, right? When x approaches infinity. There is no negative infinity per se. X only go down to approach 0. So if b is greater than 1, then y approaches infinity. If b is less than 1, y approaches negative infinity. It's going down, but it's going slowly, but it will go down to negative infinity. So there is one-sided end behavior only.